We're back today. I had some audio issues yesterday. I don't know if I got muted or if the mic wasn't set up. I think I got muted because I was using a sync collection that I hadn't done the changes for the music on track one. So we're going to be continuing going through some of the examples. Second chapter of this book, Artificial Intelligence Programming with Python, from Zero to Hero. Okay. Which one did we do? We did Math Pi. And so let's turn a page. Exercise. Based on a Python Pro reads a list of floats. And it bores me. Plotting's important for visualizing the data. Python has a powerful matplotlib library similar to MATLAB's plot function. Example 214 shows an example of using this library to plot. It first uses import matplotlib.pyplot as PLT to import the library's pyplot function. It also supports another useful library, NumPy. Now, NumPy's one you're going to be using a lot in game development too, which is helpful for dealing with numeric arrays, and it then creates an array of 100 numbers called x using the range function x equals 0, 1, 2, all the way to 99. Remember, in computers, if you have an array, unless you do some, +1 when you're inserting the array, it's binary. So 0 is something. If I say, hey, you have 0 bananas, well, to you, you're thinking, I don't got no bananas. Well, in computer world, 0 bananas just means you got 0 bananas, right? It's itself, which the concept of 0 isn't that old, so I think, I don't remember correctly from my college days, but I believe it came to us through, a concept of Indian origin. It might have been Muslim Arabic origin too, but I one time read a book years ago about the history, the history of 0. Very interesting book. It then calculates the sine wave of the array x using NP-Syn. So this is like crap I don't know anything about. But hey, let's have a little bit of fun and let's do the example together. Maybe you are more of a math person. Like I said, math never excited me. Example 214. That's why I like computers, right? They can do that math for me. 2.14. We got it. Okay. Come down here. So the first thing we're going to do is we're going to do an import statement. And we've done import statements already. Matplotlib. See? It pops that up for us. .pyplot. See? Pops that up for us. That's why IDEs as PLT. So what we're going to do, we're going to open up one of our recent programs. Okay, let's open up the math one, right? So if you notice here, we say import math. So then we're just going to reference those functions, by using math.py. Simple. I know, okay, this pi is, functionality off of the math library. I get that. Simple to do. Well, why is this different? Well, would you want to type matplotlib every time? So this as statement basically lets you create, you know, not a variable, but kind of like a variable of this object, because think of these libraries as objects. I do because old school object oriented programmer. So now when we reference it, instead of having to type matplotlib.bob, I'm just going to type plt as Bob, right? And do something descriptive that makes sense to you, right? Since you're going to be plotting it, they figured plt, that would make sense. And, for them it probably did. And we're going to do, now this one, it isn't as long, but we're going to import, this first time, is that a capital? Nope. And you can hit tab too, you don't have to right click on it, as MP. Okay, now if you noticed, look at this. As, see how it's saying, hey, MP. So that means that MP is kind of a standard. Now you could call this anything you want, right? If it could only be called one thing, it wouldn't ask you to call it anything. But you should go by standards if you know them or they're available and the ID will help you with them. And again, though, here's the one thing I want to tell you. Always use the same ding-dang thing for specific libraries. So this way, the programmers working with you, if there are any of them, they know, okay, yeah, we've decided as a group that MP is going to be NumPy. So if I look at code, I see MP. After a while, your brain will see that as the other. But if every time you create a new import statement or a new variable, if for whatever it is you're referencing, if you give it a different name or a different number, then it's going to be harder for you when you're actually trying to solve problems with the code, clean out the bugs and stuff. It's also going to make it harder for when people at your organization read your code, there's not a consensus. So it's important to use, because like I said, if I pop this up on a server, up on Reddit, everybody would know. Like down the road, if they see me do MP, they're going to know, oh, okay, this is probably NumPy. Okay, so it's important. Come up with standards as a programmer and use them over and over and make sure those standards make sense. And if you go to a company and they go by a different standard, well, you know what? You got to change. Now, if your standard is actually so much better, your naming convention is so much better, well, then get them onto your side. If it is, developers aren't, for the most part, idiots and morons. They tend to be, critical, and, they're open to these ideas. Okay, I'm losing some words there. So, okay, so now let's do this one. I gotta put my book into the light. A little low light. So x equals, and we got a square bracket. Now remember, I'm learning this with you. I'm not a Python developer. So I for I in range and then so what we're doing here is we're setting up a multi-dimensional array. So we talked about this a little bit. So basically I'm going to say, okay, the variable x, right? This is letting me know it's going to be part of a list, right? So, and it's going to be I, and it's basically saying, for each element, it's going to be range 100. So it's going to create an array of 100 items. So if I put 10 here, I would have an array that would hold, it would hold 10 items, not 100, okay? So now we're gonna like go into it and kind of make it a little crazy here. Now we're getting into some actual coding besides just printing stuff. So we're gonna say x equals, now remember, NP means NumPy, right? NumPy array, and it's telling you how to finish it. And you know what? It's the exact same thing. So you hit tab that the IDE is telling me to do. It knows how to create a multi-dimensional array. That's the beauty of using an IDE, and an IDE that's set up with the language that you're using. Like if I wouldn't have put in all the stuff for Python, I could have still wrote this. But if it was trying to make sense of it as, say, a C++ program, I'd be getting errors left and right. And it wouldn't be giving me good, when it does this, hold on. When it does this kind of a thing, that's called IntelliSense. Believe me, and I remember the days when we didn't have such a thing. So, it's nice. And again, I'm sorry how slow my typing is. My hands don't work that good. Okay, so now we're going to say x, and we're getting into some math again. 2 times, so I don't understand everything we're doing at this point. NP oh, that's pi. Listen to a little jelly roll. I thought it was a PL. I'm like, what? X times 0.01. Okay, so I'm taking this array and I'm saying 2 times pi times x times 0.01. Maybe you guys, some of you all know what that's for, right? We'll find out when we figure it. Okay, so now we're going to set the sine wave. So y is going to equal np dot sin x. Okay. And now we're going to do the plot. Okay, so that's going to be plt dot plot. All right. Hit tab, let it finish it for me, and it needs 2 values in order to plot. I'm assuming this, think of this as kind of like plotting, like, say, a graph, right? So it's going to say, hey, and that's why I said you use NumPy a lot when you're doing graphical things and that, because you're going to be, setting elements. You're going to be saying, oh, put a dot here, there's a dot there, connected to with a line, stuff like that. Which we won't do with this book, but maybe I'll get a graphic book and we'll do some of that. So now I'm going to put a title for it. So I'm going to say this plot.title, right? Oh, it's going to need a couple more letters, right? And then we're going to tell it send plot. Right? So that's going to set a title for what we're showing it. This might be interesting. We're going to set a label, right? So we're going to say what we're dot label. Oh, look at that. See? It already knew dot label, but oh yeah, it was X label. See, it knows better than me. X label, and that's going to be X, right? And then in this situation, we say we hit end, it'll go to the end of the line. Okay, and then we'll say PLT dot, and what's this? Y label. All right, and then we do boom, boom, send, and then we end it, go to the end of the line. Now, what do you think? Okay, now here's we're going to say display it, right? PLT.show. And this is when you start using some of the graphical libraries, you'll be doing stuff very similar. So yeah, this is artificial intelligence. But these are things that if you're going to make a game, this is like code. You're going to see code very similar to this within a game. So let's see. Do you think this code example is going to run? What do you think? Put it down in the comments if you thought it was going to run or if it's not going to run. Okay? It looks like it's going to run, but we'll find out. Okay, we got to give it a name. What? Oh, we got to tell it Python debugger. Okay, it's doing something. Oh! Look at that! Woo! Look at that! Isn't that cool? See? So we did like a little graphical program. But like I say, you'll use NumPy a lot. I've seen a lot of programs when I looked over their code and stuff and when I was researching like how to do game development, that was one of the frameworks they did a lot. But you see, so that's kind of cool. So let's stop this. Let's play with this one a little bit, right? So let's take this. This is where the work is being done, right? So let's Control-C this. And let's Control-V it. And this is how if I want to fiddle with stuff when I'm coding, say we comment that out or remark it out. Remark is what we used to call back in the basic days, if I remember correctly. Okay, so we're saying x equals 2, so it's so let's change this. Let's see what it looks like. Let's make this a 3. Okay, Control-S to save, and let's run without debugging again. It took it a minute though. Okay, so it popped over here. So by changing that, that's what it looked like. That's what it looked like compared to. We'll comment this one out. Now remember what that one looked like, right? And let's come here and let's stop debugging and run without debugging. Now remember what that one looked like. It looked kind of like a wave going up and down. Well, now it's a wave like this, as opposed to, it was what, 4 hills and valleys, I think, in the last one. So that's kind of cool, right? That was a pretty fun example. I'm only into the second chapter so far. I think, okay, it's got, in this chapter, there's a bunch of stuff. We start getting into AI data sets. We got maybe 6 more pages of this chapter. But I'll say, we got a plot 2 one coming up. And then there's an Excel one coming up. And an Excel 2. And then it talks about different types of AI data sets, which is interesting. And I'm assuming, things like UCI machine learning repository, ImageNet, COCO common objects and context. So it's just going to give you a quick little overview of the different data sets. And we go into part 2 after this. And in part 2, we learn machine learning and deep learning. So I'll come back with some of those examples. I'll go through on my own the rest of this book. I'm not trying to go through the whole book with you. I'm just kind of giving you some tips on coding and learning a new language and learning with you. So I hope you jump on. I hope you watch more in this series. And, if you're into coding or you want to be a coder, this is a great way to start. Like I said, I started to code, I can't even, back in the 70s, using BASIC. So, and that was a simple language. See, I feel sorry for the kids today. That's why I think Python's really good. Because when I started learning, we had simple machines and we had simple languages. It was easy to figure out. And over time, it was easy to increase the complexity of the architecture of the computers and increase the complexity of the languages in order to do more meaningful work. If I would have jumped straight into the type of computers we have today and C++ or assembler, I couldn't learn assembler today. There's too many registers. There's too much, that's beyond me. I'm not the kind of programmer I'm not smart enough or good enough to write my own compilers. I thought of doing it, but again, there's why? Kind of a thing to it. What I enjoy is solving problems with computers, personally or professionally, and making games. I enjoy computers for that. But I think Python, it's an interpreted language, and it doesn't really do a ton without these additional libraries. And sometimes you might have differing opinions as to what the library should be. So you might have 2 or 3 different frameworks to choose from. Say if you're doing audio or video or, which to me, graphical stuff, there'll be different science libraries, different business libraries. Maybe at your company, if you use Python, they've created their own libraries. Like at Progressive, we had a framework we called TCA for thin client architecture, and basically we did all our work. At the beginning we used BASIC, Visual Basic, but then we converted over to C Sharp, and the framework TCA was written primarily in C++. And so we interacted with this framework. So you might come to Progressive as a college hire and learn this framework. Well, that don't mean you're going to like go to another shop, because we were very specific to our organization, right? You're not going to take TCA with you. When you go to another company, you might be like, wow, this is great. But I'll tell you, a lot of the developers did not like interacting with TCA. They wanted to code, as opposed to describing what they wanted to do. It was like a framework, so a lot of it you didn't, you would do little bits in C Sharp, but a lot of it you just did in XML. And you had to know stuff, but you didn't step through. It wasn't easy to step through things like that, but it worked really good for us. It allowed us to do frameworks quickly. The business liked it, but then kind of the developers had a bit of revolt and said, we don't want to use it no more. And they're like, well, you got to. And then over like a month on the weekends, a couple developers completely rewrote our application using just the .NET framework as opposed to TCA. And the business was like, well, this rocks. This will let us do something. So there's always a trade-off depending on whichever framework you choose to use. But Python's a pretty simple little language, it seems so far. But the complexity comes in what I can add to it. So again, you could come in here, you can learn basic math, you can learn how to write things, you can learn inputs, you can learn how to create variables and arrays. But then when you want to do more complex stuff, say you want to generate computer music, well then there's going to be libraries you're going to import. And this import statement, you're going to do that in C++, you're going to do that in C Sharp, so because say you're writing a C Sharp app, you don't want to add every namespace to your application. Namespace is a collection of objects, say, right? You're not going to add all of them, because then your software is going to be so big it's going to barely run. You're going to add the ones you need for that program. It's also better from a security perspective, right? If there's a bug in, collection of class A, well, you're not using it. It don't matter for your application. But if you loaded everything, well, every time we found a security, you'd have to go in and remediate it. So it's always good. And sometimes you might, as a programmer, you might add more than you need. So you'll go in there and you'll rewrite the code and be like, oh, here's a better way. Well, then you remove these statements, right? You don't load what you don't need. And so to me, that's one of the things kind of be cognizant. Now, there are tools, refactoring tools, that'll let you know, hey, you're no longer calling this, and then you can go and you delete it. If it's a compiled language and you've put an import statement, but you never use it within the program, most of the compilers would just disregard that instruction. Because it's like, oh, they're never using NumPy, so why did we reference it? Because like I told you, when you compile a program, it streamlines it first, right? Goes through, and it's like, okay, let's make sure everything is good that we can convert it to machine language. Oh, we don't need this. Wait a minute, you have this variable